Hamming codes. This is very important. Hamming codes. Okay. See what we did so far. We are going to have m data bits, and those m data bits you are going to send it to other side, meaning that I am trying to send it from the sender, and at the receiver side I am going to receive m bits only, but there is a small change in these bits, like it can be 1 bit error or 2 bit error or some kind of maximum of m bit error also possible, right? So because reason, the initially we discussed the basic approach. In basic approach we can able to detect the error, but the problem here is it is very hectic process, and we cannot able to accommodate more data, right? So this is the reason we are moving for parity bits. In parity bits, the problem is if more than one bit is changed, or some even number of even number of bits are changed, then this procedure won't work for you, right? So observe this one, as this bit is changed and this bit is also changed, there is no error it is saying, but actually there is an error. That's the thing, right? If the number of bits are changed by more than one bit, then the parity bit won't work for you. Similarly, in checksum also, as bits are changed, compulsory your result may be get all zeros when you are going to complement in the receiving side, but that is also invalid procedure, right? So to overcome these things, to overcome all these things, we are moving for Hamming codes. In Hamming codes, we can able to detect the error. At the same time we can able to correct the error. That is the advantage of Hamming codes. Okay, but here you have to follow certain procedure, where that procedure is very simple. See, I am trying to send m data bits. For this m data bits I need to send p parity bits. That's it. If you are going to do this, then you will solve the problem of that error detection as well as error correction. How it will happen? Try to think. See, if I am going to send m data bits, p parity bits, in how many bits the data may be changed? M plus p bits data may be changed, right? So as I am saying that, if I am saying that m bits are data bits are sent, 1 bit, 2 bit, or m bits are going to be changed, right? If I am going to send m plus p bits, data is going to be changed, or there is no change in error. So this one represents there is no change in the data, right? So m plus p means what? These are the many number of errors occur. Okay, fine. So the procedure will look like this. So when you are going to do some kind of parity mechanism, first thing is you have to write down the message bits as well as parity bits. How we are going to do now? So you have to take P1, P2, D3, P4. Sorry, it should be D3 only. It should be P4 and D5, D6, D7. Don't think about any new. Here I would like to simply say where I am saying that it is parity. Parity means it is powers of 2. 2 power 0 is 1. 2 power 1 is 2. This is 2 square. And this is 2 cube. Right? 2 cube is 8, right? P8 is the parity bit. Right? Like this you have to set your data, right? So meaning that if I am going to have m data bits, how many parity bits are required? For example, if I am going to have the data, 1011, I need to send 1011 data to other side, from sender to receiving side. How many parity bits are required for me according to this particular pattern? Try to fill the data, right? Don't think about the parity. Here you need to fill 1011, right? From the right side you are going to fill. So D3 as 1, D5 as 1, D6 as 0, D7 as 1. Do we require P8? No, no need. Meaning that in order to represent M data bits, you require P parity bits. What does the P represents? P represents the powers of 2. Try to think. See, if I am going to have 5 data bits, 5 data bits, uh, 5 data bits, how many parity bits are required? Right? If I am going to have 5 data bits, what is the D9 reference? Here I have to accommodate. If I am going to accommodate, compulsory required one more parity bit, right? So if I am going to have 4 message bits, you require 3 parity bits. If I am going to have 5 message bits, you require to have compulsory 4 parity bits. Like this, you need to find the relation, right? Is there a relation between these two? We can define as 2 power p greater than or equal to m plus p plus 1. This is the relation that you need to define the to answer the number of parity bits are required, right? If you are going to simply observe 2 power 4 is greater than or equal to this one, 2 power 5 is greater than or equal to this one, like that. Okay, fine. See, I am saying that here, if you would like to represent m data bits in the Hamming code representation, compulsory you require the value has to satisfy this particular property. This many parity bits are required. Okay, fine. Guys, as I said, like 1011, 1010, assume that is my data wants to transfer. How we are going to represent? You are going to represent parity 1, parity 2, D3, P4 because it is 2 power 2. D5, data bit 5, data bit 6, I think data bit 7, right? So 1, 0, 1, 0. So what does this parity bit defines? So this is the heart of the concept. Parity bit defines. So there is one pattern which is following. We can able to follow. I said whether it is an even parity or odd parity. Assuming that for time being, I am trying to follow as even parity. Even parity, right? P1 value defines. P1 value defines P1 comma P1 comma, you have to left out one location, then you have to include D3 and you have to left out one location, then D5, then you have to left out one location, then it is D7, right? Now what is the value of P1? Don't know. What is the value of D3? 0. What is the value of D5? 1. What is the value of D7? 1. Now to make the P1 value as even parity, what is the value you have to place here? That should be 0 because 2 ones are already there. So P1 value is 0. Right? Now to find out the P2, you have to write two consecutive terms P2 comma D3, and you have to left out two terms and you have to write the next two terminology D6 comma D7. What is P2? Don't know. What is D3? 0. D6 is 0. D7 is 1. Right? To make this as even parity, P2 also even parity, what you have to do? You have to add 1 here. So 1 I have added. Okay. Now to find out P4, you have to consider consecutively 4 terms. If there are any other terms are there, 4 terms we have to be not considered, then we have to consider 4 terms, right? So P4 value, if you are going to find out, P4 comma D5 comma D6 comma D7. D7, right? So what is P4? Don't know. D5 is 1, D6 is 0, D7 is 1. Now to make this as even parity, what will I have to place here? 0. So I have to place here 0. So this is the data I want to send from sender side to receiver side. So at the receiving end, my data will look like 1 0, 1 0 0, 1 1 0. Now what the receiver will do? Receiver will first check for error exist or not. If there exists an error, then it will able to find out the correction. First, let us check whether there is an error or not. Right? So how can you do that? So for that, I will do a simple modification in this receiving side. See, at the receiving side, I am trying to say that I received in place of 1 as 0. In place of 1 as 0. At that time, obviously, you know, right? So there is an error detection, right? How can I do that? Right? So the thing here is, try to find out again the relation. This is P1, P2, D3, P4, D5, D6 and D7, right? Now try to find out the value of P1. What is the value of P1? Value of P1 is again P1, D3, D5, D7, right? So you have to take 0, this 0, see, I will write again in blue colors, right? This I have to consider, and D3 I have to consider, D5 I have to consider, D7 I have to consider, right? 0 0 0 1 0 1, right? 0001. Guys, with this example, can I say that P1 contains an even parity, but I got as odd parity. So I can say that error is detected. Okay. So with this example, I can say that error detected happened. Okay, fine. Now try to check out for P2. To find out the P2, you have to consider P2 D3, and then you have to remove the not consider 2, and then you have to consider these two, right? So you will get 1 0 0 1. So even parity, there is no problem. So there is no error. At the it thought that there is no problem for P2. What about P4? You have to consider contiguously 4, that is 0 0 0 1. 001, and it thought that it got an odd parity, it got an even parity. So my point here is, as I am following the even parity approach, at 81 of the parity bit side, if I got odd parity, I can say that error is detected. What about the error correction? How can correct? So it has to identify whether this is correctly, there is error at this side. Try to think, right? So guys, observe, I will try to write some particular logic here. At the P1 side, I am going to make 1. At the P2 side, I am going to make 0. At the P4 side, I am going to make 1. What is this 101 value? 5. What does the D5 means? Meaning that this 101 defines the error location. As the data here received as 1, I can able to modify it as 0. So now this is my correct data. How you got this one? Okay. Sometimes you may get like 100, right? Then what will happen? See, you have to write like this. So at the checking side, so you have to think as, you have to arrange the data in such a way that P4, P2, P1. Right? As this is a kind of a palindrome 101, or in any order if you call it as 101, so there is no problem. Sometimes you may get 100. At the time you have to question, right, whether it is 100 or 001. So the reason, the point you have to do is, you have to make them arrange in the form of P4, P2, P1, and this I will technically call it as C1, C2, C3. Technical call it as C1, C2, C3. Then this is my data. So 1, 0, 1 is the location where I got error. See guys, what does this 1 means? What does this 1 means? What does this 0 means? So this 0 means it is already even parity. This 1 means odd parity. This one also means odd parity. Odd parity. Guys, if you observe here, P4 represents what? C1, P2 represents C2, P1 represents C3, right? C1 and C3, C1 and C3 means intersection of, so when both are ones, I can say that intersection of C1 and C3. What is the intersection of C1 and C3? Intersection of C1 and C3 is common things are D5 and D7. D5 and D7. And what is this C2 0 means? I am going to subtract from C2, right? D5, D7, I need to remove it from this P2, right? If I am going to set difference D5, D7, P2, D3, D6, D7, what you are going to get? You are going to get the data which is not present in the second set, that is D5. That is what you got, right? So this is the way you can able to correct the error. I hope you understood clearly, right? So for your simplicity or for your understandability, I will take one more example with direct explanation. For example, I would like to transfer a 4-bit data, or I think in the earlier I have taken 4-bit only. Now I will take some 4-bit, okay? So because if I take 5 bits, it will be long. So 0001, 0001. This is my message data I am trying to send, right? So for this 0001 data, I need to add parity bits. Parity bits are in the form of P1, P2, D3, P4, D5, D6, and D7. So my data will look like 0001. And I need to find out the parity P1. P1 value means what? It is a combination of P1. I need to left with 1, that is 1. Sorry. I have to write separate if for your understandability. So this is empty 1, empty 0, and empty 0. So to make this as even parity, I have to make this as 1. This is for P1. What about P2? I have to consider these two, that is empty comma 1, and I have to left these two, and I have to consider these two, that is 0 comma 0. So to make this as even parity, I have to consider here also 1. Next, to find out the P4, I have to consider all these 4. So to make even parity, I have to compulsory make it as 0. This is data, right? Now at the receiving end, I received this data perfectly, and it is going to calculate. C1, C2, C3, and as there is no error, there is no problem. So obviously nothing happened. But if you thought that there is an error change, there is something change, right? For example, 0, 1, 0, 1, 0, 0, 1, 1, 1. Guys, if you are able to observe here, I modified how many bits? I modified only 1 bit. So meaning that this Hamming code procedure works for 1 bit error correction, not for many bits. Okay. So now try to calculate again P1, P2, D3, P4, D5, D6. So should be D6, it should be D7, right? So now if I calculate the P1 value, P1 is 1 comma 1 comma 0 comma 0, 0 comma 0. So I got even parity. So there is no problem. If I calculate P2, 1 1 1 0, right? So P2 means these two and these two, right? Now I got odd parity. Obviously I can say that as odd parity got, so I can say that error is detected. Now I will calculate P3. Sorry, it should be P4. P4 means combination of all these 0, 1, double 0. So as I got again odd parity, I can say that error is detected. But the question is where the error is. Where the error is. So that is what I can call it as error correction. To make do that, so what you can do, you can make as check bits C1, C2, C3. What are these check bits? Those will get from P4, P2, P1. Right? What does the value of C1? If there is an odd parity in P4, I can say that this is 1. So there is P2 also odd parity, so it is 1. And P1 is an even parity, so it is 0. So what is the meaning of this 1? 1 means the bit is modified for the P4 value. The P2 means this one. So what is the meaning of 110? 110 value is 6. 6. If you calculate the bit number 6, so bit number 6 is modified. So if you are able to modify the toggle the one with the another value, that is 0. So your result will be 000 0 triple. This is your answer. So this is the way you can able to use Hamming code procedure to find error detection or not existed. If error is there, then you need to rectify that error. We can call it as error correction. I hope you understood clearly. Thank you.